The motivation behind Java generics is having the compiler keep track of types, parameters, to perform the type checks and the casting operations. The compiler guarantees that the cast will never fail. Instead of relying on the programmer to keep track of object types and performing casts, which could lead to failures at runtime, difficult to debug and solve, the compiler can now help the programmer enforce a greater number of type checks and detect more failures at compile time. Now let's start with an example of normal Java code. We're going to go here and create a new class. We're going to call it Java Old Way. Now in here, we're going to import an array list. We're going to also be importing a util list so we can have something to cast to. We're going to create our list. And we're going to be adding an integer to this list. We're going to be creating a string so that we can create the error. All right, as you can see here, we have our array list of type list, and we're going to be adding an integer to it. Okay, what happens is that at runtime, when it tries to cast this integer to a string, it is going to give us an error. Let's run and see the results. Exception in thread main Java class cast exception. Java.lang.integer cannot be cast. Now let's take a look at Java generics and how this can help us to write better code. Let's copy in the import statements from our old class, which we'll be using in this class as well. Now let's use generics to enforce and do the typecasting for us. We'll be adding the new integer. And we're going to be doing our casting here. Let's see what happens. Okay, as you see, the Eclipse IDE will not allow us to compile this class. It already gives us an error which tells us cannot cast from integer to string. So even before compiling the class or running any code, Java allows us to make sure that we are actually using the code correctly. This is the power of generics.